All right, so continuing on with our lecture on essentially consumer theory, but we're using consumer theory to what essentially is have a conversation about how do people organize their spending and saving in the current time period, and then how do they do that in the future time period? And the sort of economic response to that is that because we think about consumption in the current period and consumption in the future period as essentially the same process as a consumer choosing a bundle of goods and services, then the idea is that there is some interplay between current and future consumption. What we consume versus what we save today is obviously going to affect what we can consume in the future. And so we're just going to go through some more of that, add a little bit more detail, and then we'll finish up this lecture with a conversation about a few ideas, a few theories in economics that come from this particular discussion. Okay, so just to kind of remind you where we are, graphically, what we learned about in yesterday's lectures, sort of the two key things is that consumers are trying to maximize their utility and then subject to an intertemporal budget constraint. We refer to utility maximization as constrained optimization. In many ways, this makes economics interesting. If people were able to maximize their utility and they weren't subject to a budget constraint, then economics wouldn't be very interesting at all. The fact that consumers are making decisions according to their budget also means that they are making decisions according to, in the traditional sense, the prices of the goods in question, as well as income. And you've seen income written as both I and M, so just to kind of keep that in mind. And so, in a sense, the sort of problem, what we refer to as the consumer problem, is to essentially incorporate the information of prices and then the information of future income. So we think about income and we think about consumption as flows, right? That's a term that we've used quite a bit so far. And the idea here is that we want to think about economic behavior as existing in this sort of time period setup where there is economic activity flowing throughout that particular time period, and then there's a sort of end to that time period, and then the next time period there's going to be flows into that particular time period. And so whether we're thinking about consumption from consumers, whether we're thinking about investment, and whether we're thinking about GDP. Famously, GDP is a flow. It is the amount of money essentially spent in an economic system in a given year on making all of the various things that are made in that economic system, and all the things that were consumed in that economic system. And so we want to kind of wrap our heads around this idea of thinking about economic behavior as sort of flowing in to time periods, and the characteristics of the time period, the economic conditions of the time period, the psychology of the time period is ultimately going to affect the decisions that people make, what they consume, what they save, so on and so forth. And of course, the implications of this are huge, right? I mean, how much people save versus how much they consume has huge ramifications to our macroeconomic system. In fact, Keynes famously talked about the paradox of thrift, which I think is sort of an interesting kind of idea to think about here. So the paradox of thrift. That's a really ugly eye. Sorry for that hideous eye. But the paradox of thrift from Keynes basically said that when people have this incentive to save, and saving is sort of typically viewed as a good economic decision. And so, in a sense, we policymakers will want there to be savings in their economic system. Of course, an implication of, for example, saving in the first time period is that you consume less in the first time period. And so if a lot of people are consuming less in the first time period, then the sort of macroeconomic aggregates may not necessarily be good. And then therefore, when we head into the second time period, those lack of flows in the first time period may end up affecting flows in the future time period. We don't really get at it too much in this class, right? We think about there being sort of two income realizations. You get income in the first period, and then you get income in the second period. Now, in the real world, this and this are potentially connected. For example, it might be the case that the if your income, for example, is sort of has upward pressure put on it in the current time period one, that may mean an expectation that you're going to see future income rise, right? So there's a lot of sort of forward thinking in this, and there's an assumption that consumers and investors are forward thinking. Now, we might sort of debate that. We might debate to what extent this sort of representative household that we've been talking about actually represents, let's say, the average household in the economic system. And of course, we can always have conversations about what assumptions seem to be okay and what assumptions are sort of pushing us to the brink of it no longer making sense. So it's always a balancing act. So anyway, again, to kind of just really quickly review sort of where we were yesterday, the big thing we learned is that utility maximization is constrained optimization, that these indifference curves here all represent levels of utility, and the consumer wants to consume on the highest level of utility that they can, but of course they are constrained in their ability to do so by their budget constraint. And so ultimately, utility maximization ends up being a sort of game of what's the best I can do with what I have. And so we learned that there is a mathematical optimization here. So 0.3 is optimal, and it is optimal in particular because the marginal rate of substitution, which is just the slope of the indifference curves, is equal to the price ratio, PX, or I'm sorry, excuse me. I'm thinking about typical utility functions, right? So typically the marginal rate substitution is equal to the slope of this budget constraint, right? Slope of the budget constraint. And typically the slope of the budget constraint when we have, X1 and X2 is that the slope of the budget constraint is just PX1 over PX2, right? That's everybody kind of gets that particular idea. Well, here, if you recall, we're not thinking in terms of consumer goods, we're thinking in terms of consumption. So consumption in time period one, consumption in time period two. And the idea here is that essentially you can think about consumption as being about actual units of products. And so the units of products, CT, cost CT, essentially is the way to think about it. And so this budget constraint doesn't have the sort of typical price ratio slope, but what it does have is it has a slope equal to 1 plus R, where R is the real interest rate. All right, so the slope of this budget constraint, oops. is again equal to 1 plus r. Now, one thing I wanted to mention that I had not mentioned, and there's probably a lot of you that have sort of wondered about this. Obviously, both the indifference curves and the budget constraints are downward sloping, right? So the slope of the indifference curve is negative, and the slope of the budget constraint is negative. You'll notice that I don't ever really have those in there. And the reason why I don't have them in there is because this condition, MRS equals 1 plus R, you can just get rid of the negatives. And in fact, very often I will frame this as the absolute value of MRS set equal to the absolute value of the slope of the budget constraint. So just to kind of put that point, if you were a little bit confused as to why I never mentioned the negative, despite the fact that these lines are very negative. I just sort of skip that step, and then sometimes I kind of forget that I probably need to explain that to students. So now the bigger point that we wanted to make yesterday was also that where you end up in terms of this utility maximization process says something about your particular preferences. So when we think about this particular spot here, where you end up in terms of optimization is, of course, going to be a function of your income. It's going to be a function of the real interest rate, but it's also going to be a function of those preferences that we've been talking about. And some folks just would prefer to consume in the current time period, and then other folks would prefer to save in the current time period and consume in the future time period. So this essentially kind of bifurcates us into sort of two different types of consumers, and that's what we're going to kind of start off this conversation with here. Okay, so let me go here. All right. So again, the idea here is that the utility maximization process produces a consumption function. So we can see that consumption in the current time period, CT, is equal to is a function of, I should say rather, let me get rid of that splotch there, is a function of the current income, future income, and the interest rate, right? Now, the sort of interesting point here, of course, is that the consumption in the current time period here is not simply a function of current income, but is also a function of future income. So basically, I will consume today with respect to what I expect to receive in the future. And very often in these simple dynamic savings models that we've been working through, we will assume that YT and YT plus 1 are known. Well, we know YT because YT we're experiencing today, but we will typically assume that YT plus 1 is known. That doesn't need to be an assumption we make. We'll talk here in a few moments about what that would look like if we didn't know exactly what our future income would sort of look like. All right, so increases in income are pretty straightforward. If you go back to just the general kind of budget constraint setup, an increase in income just looks like a parallel shift to the right. So if we're talking about IBCs, so this is, let's say, IBC 0 and then IBC 1, and the idea is that income is greater than it was before. And so if income is greater before, then this increases the size of the choice set, and our expectation is that people will consume more in both the future and future current time periods. So current or future income, because we're thinking about income in terms of your lifetime budget constraint, any increase in current or future income is going to increase higher consumption. And that's pretty straightforward. I don't think anybody would be sort of too confused about that. Now, to some extent, this has to do with whether the goods in question are assumed to be normal versus inferior, right? So for normal goods, the derivative of demand, or I should say, excuse me, the derivative of quantity demand with respect to income is positive. So that just means that as I make more money, my quantity demand for a product is going to go up. We would call these normal goods. There are these goods called inferior goods that you've probably heard about. For those goods, the sign is less than zero. So increases in income actually cause me to decrease my consumption of these goods. These are like ramen, the stuff that you consume as a college student that when you get a job, you no longer consume. We, of course, are almost always assuming that the economy in question deals exclusively with normal goods. And again, that doesn't sort of require a lot of conversation. Okay. Let us move on. Okay. I had mentioned a couple times about this idea of consumption smoothing. So consumption smoothing is a pretty straightforward idea. It sounds exactly like it says. And I would say that consumption smoothing is something that also has implications in terms of policy. So, for example, let's say that we know that over time, and then let's do GDP here, that over time we know that it sort of looks like this. Right. The trend, I'll do a dotted line for the trend. The trend is upwards, but sometimes the economy is in boom periods. Sometimes the economy is in downturns. And so if we were to say, look at spending as it relates to the economy, the spending actually tends to be a little bit more volatile than GDP itself. So let's say this is GDP. And then if we were just going to kind of give the behavior of a sort of spending line, it would sort of probably look something like this. It would sort of be swingier, right? So this is just spending. I shouldn't say that. We'll call this consumption. So the idea basically is that when times are good, people love to consume. When times are bad, people don't love to consume. But so what we typically try to do is, instead of this being so spiky here, we just sort of do this. And then what that requires is us to sort of save during good time periods and then borrow during bad time periods, right? So when things are good, we're making a lot of money, we're going to save some of that money. And then that way we reduce how much we need to borrow in the future time period, right? That's basically the idea of consumption smoothing. And our expectation is that essentially this is what people want to do, that people tend to prefer relatively close amounts of consumption in the first time period and the second time period. And so as a result, depending upon your expectation of income, if you think you're going to make more money when you're younger and less money when you're older, then this is going to affect your behavior today. It's going to either cause you to want to spend more money today, or it's going to cause you to save money today. So again, the point is that whatever your preferences are, generally speaking, we assume that consumers also generally would prefer to smooth their consumption over their lifetime, which I think makes a lot of sense. So why this is important is because we can think that, again, income increases are going to cause increases in demand, but the second idea would be that it's greater than zero but less than one. Okay, greater than zero, but less than one. So in other words, there's not a one-for-one increase in income and the demand, right? And the reason why that is because let's say, for example, that I earn an additional dollar in the current time period. Because I'm going to want to smooth my consumption, I'm going to consume some of that dollar today, and I'm going to save some of that dollar for the next time period. The extent to which I consume that dollar versus save is one of the most important concepts in macroeconomics, and that's marginal propensity to consume. Marginal propensity to consume. The extent to which you consume the income that you have. So think about every dollar that you have, what percentage of that dollar are you consuming? So people who consume a lot are going to have high MPC, and people who don't consume very much are going to have low MPC. Now, one of the things that I wanted to do real quick is just sort of show you some of the math surrounding this. So let me go. Oops. Okay. So this is just a very basic sort of setup here. So we have a very basic utility function. My utility is just equal to the natural log of consumption. And so then I have a lifetime utility function that looks like this, right? So natural log of consumption in the first time period, and then the natural log of consumption in the second time period. And then don't forget, in this lifetime utility, we have this essentially what ends up being a factor of impatience. Okay. Now, in a moment, we're going to see exactly how this beta parameter, this impatience parameter, ends up being linked to this marginal propensity to consume. Okay, so when you work through all of the math here, and again, like I've mentioned, I'm going to post these additional lecture notes to the Brightspace page. So when you work through the math here, and you go and you sort of set up the consumption function, this is what the consumption function looks like. So this is CD, right? This is the consumption function. And so you get the sort of typical comparative statics here. We can see that the derivative of C1 with respect to Y1 is greater than 0, right? We can see that. We can see, for example, that the derivative of C1 with respect to Y2, we can see that that also is greater than 0. And then lastly, let's think about the derivative of C1 and with respect to y1, and then let's actually do the math, right? So if we take the partial derivative of my demand function with respect to y1, what I get is 1 over 1 plus beta. So again, if I take the derivative of my consumption function, C1, and I take that with respect to Y1, it's 1 over 1 plus beta. This is marginal propensity to consume. So marginal propensity to consume is the extent to which consumption changes relative to income. Okay, so how much of each dollar of Y1, so income in the current time period, is going to be consumed? That's marginal propensity to consume. And so this is exactly that concept. This matters for all sorts of things. This matters for tax policy, government spending policy, interest rate policy, etc. MPC is something that we will come back and bring up a lot. We'll use it for many future calculations, but just to kind of show you, where this comes from, right? We said early on that the beta parameter is just essentially a measure of impatience. Here we can see that the idea behind this is that as your beta goes up, your marginal propensity to consume, as you can see here, is also going to go up, right? So we know it's a positive relationship, and we further know that it's between 0 and 1. So we can say that 0, so greater than, so 1 over 1 minus plus beta, excuse me. In the US, we typically think that MPC is greater than 90%. So very high MPC in the US. Okay, let me go back here. Stop sharing there. Well, I tell you, I haven't done this much Zoom since the pandemic. So, okay, keep it moving. It's kind of weird not to have a stopping for questions. Okay, so again, income, we know that's positive. The extent to which it actually increases consumption is going to be related to that marginal propensity to consume that I was telling you about before. So now increases in the interest rate. I had previously mentioned in class that we tend to expect increases in the interest rate to cause a shifting of consumption away from the first time period and into the future time period, right? And the idea behind that was that when, let's see here. Actually, let me just, I have another set of graphs. I'm actually going to go through these graphs in a moment too, but let me just bring this graph because I think this does a really good job here. So this is what it looks like when you see an increase in the real interest rate. So these are just budget constraints. Kind of ignore there's different variables used here because this is a different textbook than the one that we're using, but graphically it's all the same. And so as the real interest rate goes up, then we can see that the intertemporal budget constraint is going to sort of pivot around this initial optimal bundle. And so what essentially happens is that current consumption becomes more expensive and future consumption becomes less expensive, right? So that's the sort of idea behind an increase in the interest rate. As I had mentioned to you in lecture yesterday, what we care about here is sort of this substitution and income effect. And this is going to go back to that idea of consumer preferences. So consumer preferences are going to dictate whether the substitution effect or the income effect dominates, in particular, an increase in interest rate. So let's consider two different types of individuals, okay? So let's consider sort of people in terms of their initial consumption bundles. So if you're someone who's in the lower part of your budget constraint, that is to say that you're consuming a lot in the current time period, and then therefore you're going to consume relatively little in the future time period, then this means you're a borrower. Right? Because think about it. If you consume a lot now, then the idea is that you're going to borrow money today to finance your consumption today, with the idea that in the future you're not going to want to consume as much, and so therefore you'll just be paying back that loan that you took out, right? So if you consume somewhere down here on your budget constraint, you're a borrower, and then if you're over here, you can see this is period one consumption is very low, period two consumption is quite high. Here, you're a saver. Now, this textbook refers to the individual as a lender. I think it makes a lot more sense to think about these individuals as savers. And so if people maximize their utility by picking bundles up here, we know that they're savers, and therefore they are going to forego consumption in the current time period so that they can consume in the future time period. Those are the people where we get our lending money come from, right? It's one of the things we're going to learn a little bit later, is that savings, interestingly enough, savings equals investment. That's one of the sort of biggest ideas in neoclassical economics. And so if you're a saver here, then you are also a lender. Just to kind of, again, kind of sort of make that point. Okay. So now let's again, what we're sort of thinking about here is how someone is going to react to a change in the interest rate. So this individual was a borrower. Their original their original optimal bundle was right here. So you can see that essentially C1 consumption is greater than C2 consumption in optimality. And then, of course, the idea here is that the real interest rate increases. And so when the real interest rate increases, right, so this was the initial budget constraint, right? And then after this changed, then the new budget constraint is right here, right? steeper than it was before. And so now the new bundle, where the individual consumes now, is right here. This is the new bundle. So we'll say A and then B. So we went to A and then interest rate increased and this consumer went to B. So we can see that the response is to the increased interest rate to consume less in the current time period and to consume slightly more in the future time period than you were going to before. And so in this scenario, the substitution effect causes consumption in the current time period to decline. The income effect causes consumption in the current time period to decline even further. And so what we have is, so this here, right, that ends up being the income effect, and this, or I should say, sorry, that's the income effect, and then that's the substitution effect. And so the net result of this is less consumption. Okay, so increased interest rates. If the individual is a borrower, we expect less consumption in the current time period. Now, if the individual is a saver or a lender, as we saw before, again, they're going to consume much more in the future time period. So C2 is greater than C1, but then interest rate rises. And now when the interest rate rises, the individual moves here. So they were at A, they moved to B, so A to B. And you'll notice that the effect on current consumption, CT, is ambiguous. We don't actually know what happens. It looks like it might actually stay the same, depending upon how we drew the indifference curves. And again, remember that the indifference curves, these come from individual preferences, right? Preferences that individuals have for consuming now versus consuming in the future. And so for savers, the income and substitution effects work against each other, right? For borrowers, the income and substitution effects are both putting downward pressure on consumption. So when interest rates increase, if I'm a borrower, then I'm almost assuredly going to consume less in the first time period. But if I'm a saver, then the actual effect of consumption in the first time period is somewhat ambiguous. The substitution effect puts downward pressure on consumption, but then the income effect puts upward pressure on consumption. And so, again, this is sort of worth having a discussion over, because when we carry this conversation out in terms of policy, we have to consider that there are essentially at least these two types of consumers, savers versus borrowers. Okay. Oh, sorry. I thought, whoa, that was weird. It dropped my share all of a sudden. I thought my Zoom died. So what this allows us to do now is to sign our consumption function in terms of the substitution effect. Is going to be something that we think dominates the income effect always. And because the substitution effect is always negative, right? Because the substitution effect is always negative. Even if we think that the substitution effect, I'm sorry, even if we think the income effect might be positive, as it is here, our assumption again is going to be that the substitution effect always dominates the income effect.